And next up, we have Javier, he snuck up when I wasn't looking. Javier Marcos, who's going to be talking about how we've been able to do open source software securely at Facebook. Here you go. Thank you.
With the light is very hard. Thanks, Ryan. Thanks, everyone, for being here today. My name is... Oops. OK. Yeah, my name is Javier Marcos. I work in a security team in Facebook. I've been working there for 4 years now. And I am a security engineer. I work now in the development and testing of OS Query. Before that, I was working on the incident response team. I've done a little bit of red teaming pen testing, and my previous life, I was a pen tester for a few years. So it was kind of like a logical move to go from an offensive background to a defensive background, and now trying to just build things right, or at least make people to do that. And before I start, how many people here know what a continuous integration deployment is? OK, how many people know what Jenkins is? Good. How many people was aware of the Java serialization vulnerability that was exposed last week, and amongst other things, Jenkins was affected? Good, good. We are off to a great start. So the main goals of my talk are going to be to share the experiences that we've been coming across building OS Query, which is a security tool for host intrusion detection we use at Facebook. I will explain in a second what it is. Provide some examples of how to be able to achieve a hardened build process, because most of the times these DevOps environments are not looked after very well. And then show some ways of attacking and defending continuous integration deployments. So the main point is why focus on open source? Why you would like to just develop this great technology and then open source it? Well, first of all, it really accelerates innovation. You can get way more feedback from everyone that is out there than just the group of engineers that are around in your project. The software that gets written, it's better because there are way more eyes to look at it. And all the challenges that you go through building it, then they are shared across the community. And one of the engineers in the OS Query team, what he said was he wants every agent in his laptop pen tested and code reviewed, which is also a good way to make yourself to do open source. This is a bit of a summary of how the OS Query project looks like. It's quite a popular security project in GitHub. It has right now over 5,000 followers in GitHub. And the biggest number is OS Query. The other one is related to the whole Facebook open source project, which we have a little bit over 2,000 commits, 496 forks, and then it's one repository. So it's kind of tiny if you compare it with the whole open source in Facebook, but still is pretty big within the security community. And then we open source it. For us, GitHub is our source of truth. We have everything in GitHub, issues for things that happen, the code, discussions about what things to implement next. And we wanted to open source since the very beginning. We just make sure that everything was working and ready. We got our first commit in June, and then we went to release day. And the main point here is that building an open source project for security, it's really challenging, because you don't just need to provide something that works and is secure, but also you need to provide proper documentation, proper configuration steps and details for people to be able to just do the same, integration with other systems. So we didn't see any big contribution until pretty far down in the timeline. And then today we have like a pretty good community. It's amazing, and then they are really good at reviewing when we do things wrong, which is often or not, whatever. And it's a pretty nice experience. So let's explain a little bit what OS Query is for the people that haven't heard about it. So OS Query is a way to explore your operative system, but using SQL. It's basically a host instrumentation system, supports OS X and Linux. And the main thing to take into consideration is 100% OS API usage. It doesn't do any system calls and parsing outputs, no for execbs or anything. It's basically, it sits on top of the operative system, and all the tables are native. So a little bit more to explain. So in operative system, you have things like concepts, like a process or users. So you can, with SQL, you might be able to query that, saying, for example, get me the PIDs and the names for all the processes. And then those things that you are looking for within those concepts can be called the attributes. And then you can apply to them some constraints that, for example, here, get me all the processes for the UID that is not 0. And the magic thing here is that you can then apply a different type of concept, which could be the users of the system, and join against that concept. And then you can just query or join any other part of the other concept that you are applying. So with SQL, it gets really powerful to just see what's the status of your operative system, retrieve information that happened in the past, or things that are going to happen ongoing. And the concepts are like the tables to join in OS Query. All of them are native. They change in different platforms. For OS X, there are some that are not supported for Linux. Some of them apply to Ubuntu. Some of them apply for CentOS. Some of them are for FreeBSD. So all these tables can be just used as the concept for operative system. And OS Query is a C++ project and has quite few components as dependencies. It's built on top of C++ 11, LLVM. It's used for building CMake. Then it's using RocksDB, Thrift. It has like a way to implement plugins, extensions, modules. Then you need to have like some kind of complex configuration and scheduling. So it's not a straightforward process to just build OS Query. And this is one of the things why we figured out that we needed what is called secure DevOps. So the thing is that the building OS Query is like kind of complex, and it needs quite some resources to be built. If you have a system that is already with all the dependencies installed, it takes 5 to 9 minutes to compile. Right now, we are supporting 10 different operative systems. And one of our goals was to, in each pull request that we get, we want to be able to run the same tests and compile in all the platforms at the same time, which is what continuous integration it's what for. But the problem is that when you have like a complicated process for the building, then it makes things a bit more complex. Also, not just compiling, but we wanted to run like a bunch of tests, regression to make sure when a bug was introduced in the code base, static and dynamic analysis, and also we ship a kernel extension. And when we are dealing with kernel extensions, you don't really want that extension to panic and then crash the people that you are running OS Query on. So you need to test that properly. So we started with a list of requirements. So what is what we need, or what is what we need to make sure that we are going to check that box? And the main thing is that we needed GitHub as the source of truth, and that was going to be public. It's a public repository. Every pull request are accepted. Anything that happens there will stay there, and then we are going to use that as the main place where we create all the things. The project is C++. We weren't going to change the project to Node.js or something like that at that point. And then it needs to support several OS X flavors. And this is important because it affects the licensing on the virtualization you are using. Well, I mean, if you want to buy thousands of Mac Minis, that's fine, but it doesn't scale. Also, this was going to be used to build packages that were going to be built automatically. And it needed to have some internet access, either to install new dependencies or when the building process changed. So that was kind of like a must. We tried to use Travis CI, but it didn't work out, because Travis CI is a great tool when your project is somewhat simpler, or like works really well for web application, or something that it doesn't really have a process that is as complex as OS Query was. So we were having problems, out-of-memory errors. It wasn't great. Latency was too high. So we had to just say, OK, let's just implement it from scratch. And then Jenkins was the best next thing that we could look at without implementing that ourselves. And at that point, it was kind of like a proof of concept and say, let's see how that works. It was kind of started small and applying all the lessons learned that I'm going to be talking about here, and then how that was able to scale when we wanted to add more systems, and that was the actual lessons learned. That if you apply good practices early in the process, it's going to be way better and easier to just keep going. So basically, at a really high level, this is the process that we were having here. So we get a developer gets a pull request in, then we get some bots that do some signing to the pull request. Then I just go review the code and say OK to test. Then we have another bot that goes review that and then lets the build begin. That's OK. So or Jenkins was how we were going to make the Jenkins to work. So this is like a very high level of how Facebook network looks like. So we have a production infrastructure, then we have a separate corporate infrastructure, and then we have what we call the vendor infrastructure. This is where we put our Jenkins on, because we needed Jenkins to be somewhere in the internet, but did have a way to expose itself to just get GitHub to send requests every time that a pull request, commit, or whatever was coming in. So we do trust Jenkins, but not so much. So we were going to say, all right, we're not going to just make Jenkins to sit there in the internet with a public IP. So we're going to just use something else. So we just put Jenkins as a virtual machine, and we expose that service as reverse SSH to an AWS box. And this, we are going to use that for something else. I'm going to explain in a minute. So we came up with, since we needed to use OS X, we needed to, in order to virtualize OS X, you need to run it in Apple hardware. And the way it works is like you can only run 2 instances in each of the units of hardware. And for us, the best way to then do it was to use Mac Minis to do that. And it all started with a single Mac Mini, ESX bare metal install on it, virtualizing, and then seeing how the thing was going. So this is how we just came up with. We got like a bunch of different systems that what we were supporting as virtual machines inside of ESX. Mac Minis are the ones that are running the whole thing, and Jenkins is an actual virtual machine inside of this, which was great. And then how we started with this? Basically, like, first approach was, all right, let's just do it. It was a single Mac Mini sitting in my apartment, and then reverse SSH to the internet. And it's like, well, this works great. But instead of having one concurrent build, we need 5. So we need more machines, more systems. Next step was just to put 5 Mac Minis on top of each other, put it in my desk, map the network port for that vendor infrastructure, and then great. But that wasn't very great, because I did that in May, and it gets pretty hot in California. Having 5 Mac Minis sitting in your desk, it makes it really hot. Plus, I could tell when something was running for like the heat that was just coming to me. And then at some point, we wanted to put more machines on top of it, so we went just for the corporate data center, and then we put 10, and at the moment, we have more. So the good thing was that at the moment, we had something that was good. The only thing we had to do is just throw more Mac Minis at it. It worked like that way. So so far, it's nothing new. It just install Jenkins, make sure that the process was working fine. How did we make it that we didn't get popped the first week? Jenkins is usually like the low-hanging fruit that in pen testings or red team exercise. Either both Jenkins previously, Hudson was the thing that's like, yeah, I found Jenkins, default password, boom, I have persistence in the network. So we wanted that to prevent, and we managed to have, like, for a year, Jenkins in the internet, no compromises that we know of. But this is the type of the lessons that we've went through. First, we wanted to have like a TLS proxy. So we can enforce that the traffic is always going to be SSL. Then we can just make sure that the host is there, and then we enforce the right ciphers. Also, we can just make sure that we use reverse proxy to expose the right service. This is just default hardening for Apache. You can get more details about how this works out there in guides of how to harden either Jenkins or Apache. Next step was, OK, what is the most common attack for Jenkins? Well, someone just go to Google, Jenkins exploit, go to exploitDB, and then gets anything that has been there. And we wanted to just make sure that script kiddies couldn't just go and pop this box. So we went to the last 3 years of O-Days, got all the paths that were attacked, and it's like, all right, we just blacklist them. It's not great blacklisting approach, but this is the one that then you can start off with. If you want to make this better, probably you could just have your instance isolated in the network and then do a whitelist approach, get like a transparent proxy in the middle, see what's the most usage or the P90 of the usage of your system, and then whitelist that, block everything else, and have like a way to test new things if you need more functionality. But this is the way that we use it. And if you hit one of these endpoints in jenkins.oscore.io, you get the Jenkins tiger, which sometimes is a bit teasing for the attackers because they then send more stuff, but whatever. Other step that we do with, we were like, okay, so Jenkins, most of the times they use really weak passwords. And how can we do that? Well, first thing we did was integrating OAuth authentication of GitHub with Jenkins. So we don't have an actual password that is the main point of entrance. So you are just one password away of having your continuous integration system compromised. So GitHub have a great API for enable OAuth and then be able to, yes, if you are in your GitHub account, then you can go to Jenkins. Also provides you a way to do ACLs, and so you can define which users of your project are either admins, normal users. It's really great. And with this, we managed to achieve one thing, which is multi-factor authentication for Jenkins, because since the authentication is done through Jenkins, then we can enforce multi-factor authentication in the GitHub account. And for example, if we have like one user that doesn't have multi-factor authentication, then we can raise that and then try to address that with either that user or drop the privileges or something like that. The other thing that is part of Jenkins and is a good addition to your Jenkins is that you have to enable the protection against CSRF, because otherwise they might phish you and get into that machine using the session of your browser. So they will have to compromise your laptop, which is harder than just send you like a phishing email or put you in a CSRF attack. And then you can enable this with one click away within Jenkins. There are other plugins that help you to harden your Jenkins instance, but this one works really well. Last was being able to say, okay, let's say, how do I access the Jenkins box? Well, you enable two-factor authentication for that box to SSH. Because at Facebook we use Duo, and it was really easy to just be able to integrate that, either with YubiKeys or push. So it was like very easy to integrate this, and it worked really great. So even though if your password gets compromised or your key, they will still have to beat the two-factor authentication for this. Last step is you shouldn't probably accept any pull request to your repo and then build it right away, because that's pretty much like putting a shell.php in your server and then putting the internet. It's just a remote code execution straight away. So you should provide some sort of code reviewing, so it's not really that easy to compromise your system. And Jenkins, again, provides you with both with the API GitHub to say, oh, okay, I want these users to be the admins for this deployment. Pull request hardening, probably you shouldn't do that. That's letting pull request to just build. It's really easy to get very trivial to get a reverse shell in your Jenkins if you do that. So this is like a diagram of how that was the first approach to the problem. So okay, we get someone who is sending a pull request to our GitHub repo. Then first thing what we do is like we have one Jenkins that gets all the pull requests and the masters after review, and it goes and builds them in the slaves that it's managing. So that's good. If the build is good, then the package gets created, and then it's pushed to S3, and then we expose it through different repos for different operative systems. That's great. Well, the main problem is that through the internet, people can get your packages. That was OK. It was working, but every morning when I was opening my eyes, like, I know another vector that we have to patch. So we was like, OK, we need to really focus on hardening these more. Because, for example, type of doomsday scenario, you get a pull request that looks fine. Even they change your README, or they get like some typo, something that doesn't really look like is harmful. Then you say, OK, to test, that's fine. It's a good code. And then right after, they just amend the request. And then right after that, they rewrite it again. So at this point, the code, whatever code that they just wanted to hide, is hidden and is being running in your continuous integration. So they can compromise either network, master, package build, whatever it's what you're running there, and then that will lead to a package compromise, and that's not good. That's okay. It's not a problem. The main point of this presentation is to be able to face these problems and say, it's fine, no problem. That's why it was a great example during last weekend when this serialization problem, basically what it was is Java was vulnerable against one thing that what Java was doing is, oh, you get a serialized object. Sure, I'll execute it right away. Okay, that's not good. But Jenkins was vulnerable. And thanks to all these steps, everything was mitigated. So mitigations against these, probably is good to use unique build host credentials, isolate all the building. If they try to do that scenario, there's going to be a race between the patching and what they are submitting. So that's why you have to have an isolated package infrastructure. And compromising a build infrastructure should not really jeopardize the rest of your continuous integration or your packaging. So the second iteration of this was we get a pull request. Then we have one Jenkins that is in the internet and is isolated and that builds things in the slaves. Then we get another secondary Jenkins that does nightly builds that gets just master commits and then does the building in the slaves, gets the packages, push them in S3, and then we can expose them. So here we have an environment that is isolated from everything else. Here, this is where we keep like the keys of our kingdom, so it has to be pretty much air-gapped and separated from everything. And can be just in the internet, comes from anybody. Another thing about the isolated signing is that even though that thing is isolated, there still might be some ways to get into it. You never have to presume that something is secure because it's secure, because you have to always presume this is going to get compromised. How I'm going to mitigate it? Which was great, the background on incident response, because you presume that you are going to get compromised always. So the key is how fast can you react? And of course, the compromise of the build infrastructure must not affect package integrity. So the idea is that the keys to sign the packages are stored completely in a separate system. So we actually went through all this trouble to build a tool that actually does security monitoring. So why don't we just use OS Query to monitor the building infrastructure for OS Query? So we just put OS Query everywhere. We reported all the logs back to Elasticsearch instance. And the way that we managed really to build a security tool that gives you visibility over your whole production and corporate fleet, it will help you as well to monitor the infrastructure that you are using for building it. So, for example, here in the table listening port, you can specify what do you want to select from it that is not just the address is not null. You can see more information here at the tables for OS Query. Or another one that is pretty good is that then you can say, OK, give me all the listening ports. Then you join it with processes. So it's going to give you all the processes that have listening ports and more information. So all this stuff is really, really useful when you are monitoring. And keep in mind that all this continuous integration, it should be always doing the same. So it's designed to always do the same repetitive task all the time. So at the moment there is an anomaly or something that goes really off the charts, that's where you have to look at, because that's something that wasn't supposed to be running like that. And so we came up with a configuration sample that we are running in all the building hosts, which basically monitors all the processes that are created with structuring command line paths and some more information. Then we put that in every single system of the continuous integration deployment. We got all the logs forwarded to an ELK with an ELK instance with using Logstash forwarder using SSL. You can find these two guides are really good to just deploying these. And then you just configure Logstash to get all the logs, forward them using SSL through to your Elasticsearch. And then you can see here, if you just sort all the process or all the commands that we're running in those machines, at the top of the list, you can see this thing that is kind of strange. And it's like, well, what's going on there? Why are you SSHing from one of these build hosts when that shouldn't happen? So really, Osquery helps you here to make sure that nothing weird is happening within your infrastructure. So the conclusion here is that most of the time, continuous integrations or DevOps are for security or doing pen tests, red teams. They're usually like they're very low-hanging fruit. This is when once you are monitoring a network or you are mapping a network and you find a Jenkins, like that's spot on, that's great. That I'm in and I got persistence. So you should really make sure that all these integrations and deployments are keeping secure, because most of the times what you're doing is just grabbing some images out from the internet that someone built because you have to support a new operative system, and you run it within your production system without even auditing what's the security on that box or what's running there. So it's kind of scary, and people should be doing that. And DevOps is not the best of the places for secure practices, but for us, it really paid off that we started doing all these practices from a very early stage, since the very beginning, since we started like building this as, let's see how it works. And for us, we were able to scale very quickly because everything that was supposed to be done within the system, it was just done right from the beginning. So education and being able to have software engineers that know about all these potential problems, it's really important and makes things to be very easy. The other thing is that you should isolate and audit everything. Well, not isolate, probably not everything, but audit everything that is running. So this is one of the points of Osquery. So you can have visibility over a lot of different Linux systems, OS X, FreeBSD. So you can have like signal generation, and then once you get that information, then you are able to take decisions or create alerting systems. In security, most of the times when you are not having alerts for too long, that means that you have no visibility over something. So that's not good. Having no signal is as bad as having too much signal, because false positives and just alerts, everything is urgent and nothing is urgent. No one looks at that. So it really pays off to make sure that you have systems that detect anomalies in your alerting system, so you can just create another alerting systems to look at things. And the last thing is that if you're using GitHub, GitHub really provides you with a lot of APIs and good practices that you can use if you are putting your projects there in GitHub. So use them since the very beginning, because they really make things very easy. So thanks very much. And well, I give you 2 minutes back, so let's go have lunch.